Hello everyone and welcome to Gradeup. My name is Ashish Sir and today we are here for the session 3 of building material. Now this is as per the RRB and SSC JE program. Okay. So previously we have done 2 sessions on brick and on cement. Okay. Now this session is dedicated to admixtures. Okay. So we'll wait for more viewers to join this session. Okay. So I hope previous sessions were quite helpful to you. Okay. Sorry. Okay, so previously we have done session about brick and session about cement. We have also discussed some questions, so I hope you are practicing them very well. Okay, practice more questions. Okay, from the test series and from daily quizzes. Quiz number 6 and 7 are also live now, so you can practice that. Okay, so okay. Yes, Vishal Datta, Lokesh, Pooja, Mubarish, civil student. Quite a unique name. Yes. Okay. So let us start with the introduction now. Now introduction to the admixtures. Okay. So what are admixtures? So as you all know, the concrete. Okay. So it has some basic ingredients. Okay, like cement. Okay, there is sand, there is aggregates, okay, so these are the basic ingredients. Now coarse aggregate, fine aggregate, you can put it under the aggregates. Okay, now these are the basic ingredients. These will definitely be in the concrete. Okay, so in addition you have to use admixtures. Okay, so admixtures. Okay. So as you can see on your screens, now admixtures are chemical added in excess of the regular ingredients of concrete to improve the properties of the mix. Okay, there are certain properties, like if you want to improve the workability, you want to improve the frost action resistance against frost action, you want to improve the durability. Okay, so all these properties can be improved by addition of admixtures. So these ingredients are in excess of cement, sand, aggregate. Okay, all these things. Okay, so admixtures are not added to enhance the strength. Okay, so strength wise admixtures may or may not provide additional strength. Okay, it may happen so that one or two admixtures definitely help, but admixtures in general are not for strength improving. Okay, they are more for the properties which such as workability and all. Okay, so admixtures are added to improve properties such as workability, setting time, durability. Okay, so this is some basic. Okay, so these are some of the basic points about the admixtures. Okay, so this is some of the basic introduction. Now types of admixtures. There are varied types of admixtures. Okay, available. You might have read in your college or during your preparation right now. You have read. Okay, so in building material there are various type of admixtures to improve certain properties. Okay, so first among this which we will discuss is plasticizer. Okay, so what are plasticizers? Now plasticizers are also known as water reducing agents. Okay, please note this down. Okay, water reducing agents. Okay, now these are organic or inorganic. These may be organic, okay, or inorganic in nature, which permit reduction in water cement ratio at same workability. Now if water cement ratio is reduced, you know the Abraham's law. Okay, so as water cement ratio decreases, it leads to increased strength. Okay, so if you are reducing the water cement ratio of the same workability, okay, you will be getting a strong mix which will have enhanced strength, a greater strength. Okay, now ensure higher workability at same water cement ratio. At same water cement ratio, with the addition of plasticizer, you can get higher workability, and this will lead to a workable mix. Okay, it will be easy for the laborers to work with this type of concrete. Okay, especially this high workability concrete is required when you are constructing multi-storied buildings. Okay, in confined areas like walls, 3 meters shear walls are being constructed, so for that higher workability is required. Okay, in such cases these admixtures, particularly plasticizers, are very helpful. Okay, now what is the working, how these plasticizers help? Now these act as a deflocculating agent. Okay, so if there are some cement particles like this, and there is some entrapped water. Okay, so if suppose this is water, okay, similarly this is some one particle. Okay, so there is some water. If you add this, now what happens is they get adsorbed on the cement particles. This is cement particle. Okay, so they get adsorbed on this, and due to this negative charge, they repel each other. They repel the cement particles repel each other, and the entrapped water is released. So adsorb over the cement and free the entrapped water. Okay, so if at the same workability, this will reduction in water cement ratio. Okay, because this entrapped water which was not earlier getting used, it will be used now. Okay, and ensure higher workability at same water cement ratio, because this entrapped water will, if for the ensuring high workability at same water cement ratio, this water will be released and it will lead to the higher workability. Okay, now dose is, now also to note, all these admixtures have a very small dose. Okay, in even less than 1%. It will be generally in the range of 0.1 to 0.4% for plasticizer. Okay, and that is by weight of cement. Okay, now reduction in water by 5 to 15%. So reduction in water cement ratio, first one is 5 to 15% less water is required. Okay, or increase in slump by 30 mm to 150 mm when we are using higher workability. We are getting higher workability. In that case, the slump increases by 30 mm to 150 mm. Okay, also examples are lignosulfate, okay, carbohydrate, and hydroxylated carboxylic acid. Okay, so these are the three examples. Especially lignosulfate is very important from examination point of view. A lot of objective questions you will often get in regarding lignosulfate. Okay, so it will be given, like multiple options will be given, and which of the among is water reducer or plasticizer. So lignosulfate will be one of the options, and that will be the correct answer. Okay. Also, yes, reduction 5 to 15%, often 10% on an average. There, as per thumb rule, 10% water is reduced. Okay, by the use of plasticizer. Okay. Yes. So this is about plasticizer. Please remember this, that they are also known as water reducing agents. Okay. Also, these two things, strong mix and workable mix, are important. Dose you can definitely keep in mind. Okay. And this example, lignosulfate, carbohydrate, and hydroxylated carboxylic acid. Okay. So these points are worthwhile to mention about the plasticizers. Okay. Now, the second is super plasticizer. Now, as you all know, we have studied super plasticizers. Now, this is super plasticizer. So, the action is similar. Okay, it also acts as deflocculating agent. Okay, it repels the cement particles repel each other and release the entrapped water. Okay, but they are chemically different. Okay, the only difference between plasticizer and and super plasticizer is they are chemically different. Now, effect comparatively more compared to the plasticizer, up to 30%, while in plasticizer it reduces water content for about 5 to 15%. Super plasticizer reduced by 30%. Okay, now examples are modified lignosulfate, okay, SMF and SNF. Okay, SMF is sulfonated melany formaldehyde, and SNF is sulfonated naphthalene formaldehyde. These two examples specifically you should remember of plasticizers. Okay, so Vishal Datta is asking what type of carbohydrates. See, any type of carbohydrate it can be. Okay. Generally, in the examination point of view, chemistry is not important to you. You will be asked directly with the names. Okay. So often in the questions, it will be said the carbohydrate. Okay. You don't need to worry about that. Someone is asking about the workability. Okay, so workability is ease with which concrete can be mixed, transported, placed, and compacted and finished. Okay, so if you are see workability. So if suppose you are constructing a multi-storied building, so the time from mixing of concrete, okay, then you are transporting it to the required place, okay, then you are placing it, you are compacting it, and finally you are finishing it. So throughout this entire process, the concrete should remain in a plastic nature. Okay, it must be with equipments you may be able to work with it. Okay, so that is known as the workability, ease with which concrete can be mixed, transported, placed, compacted, and finished. Okay, so this is workability to you. Okay, coming to our discussion now, super plasticizers. Okay, super plasticizers we are done with. Now the third one is retarders. Okay, so what are retarders? As the name suggests, okay, this will slow down some process. Okay, so what does it slow down? It slows down the hydration. Okay, so admixtures that slows down the hydration of cement so that concrete remains plastic, okay, and workable for larger duration of time. Okay, so the setting process, it slows down the setting process. So retarders leads to the more prolonged workable concrete. Okay, so normal dose varies from 0.05% to 0.2%, and that can delay the hydration up to 72 hours. Okay, so it's a very huge time with small amount of dose, so they are very chemically very active. Okay, now examples are calcium sulfate, also known as gypsum in a normal language, tartaric acid, starch, cellulose, and sugar. Okay, so all these examples are very important from examination point of view. Okay, so see, you know a very well known TCS. Okay, so in order to remember these, you can remember with retarders, you can remember this acronym TCS. So T is for tartaric acid, C is for cellulose, S is for sugar, starch. Okay, so with this you may be able to remember this very well. Okay, so with retarders, this is TCS, is tartaric acid, cellulose, starch, and sugar. Okay, so these are the examples in examinations. The questions related to these appear very often. Okay, so with respect to retarders, examples appear in competitive examinations. Okay, so this is about retarders. Now the next is accelerators. Now those were retarders. Accelerator, you may take a wild guess. Okay, so admixtures that fasten the hydration. Okay, so that concrete gains the strength at greater pace. Okay, so for early strength, so that the concrete becomes hard very early, we add accelerators. Okay, so the normal dose varies from 0.1% to 0.2% by weight of cement. Okay, all these percentages are by weight of cement. Okay, now common applications are cold weather concreting, okay, pavement construction, and emergency repair work. Now among all these, you can definitely highlight a thing that in this you require early hardening of the concrete, you require early strength development. Okay, because in cold weather concreting, if the concrete doesn't become hard early, then it will lead to a frost action. Okay, so it has to harden fast. Similarly in pavement construction, because you are inhibiting a traffic. Okay, so that's why pavement should attain strength early. Okay, so that as soon as possible you are able to leave the traffic, okay, as it is. Then emergency repair works for emergencies. Okay, so for that early strength is required, so accelerators are used in that case also. Now examples are calcium chloride, sodium chloride, sodium and potassium hydroxide, and formaldehyde. Also, I would like to add one more, that is silicates. Okay, various types of silicates are used. So I think that that is worthwhile to mention. Also, there is one more. Okay, ammonium chloride. Okay, so all these examples, particularly examples I have been telling from the start of the session, that examples are very important in this lecture. Okay, so calcium chloride, sodium and potassium hydroxide, formaldehyde, silicates, and ammonium chloride. These are the examples of accelerators. Okay, now the other one is there now air entraining admixtures. Okay, so this is the last among the admixtures. Now, what are air entraining admixtures? Air entraining admixture that entrap air bubbles in between the voids. Okay, so in the concrete, if suppose this is concrete, okay, so minute air bubbles will be left. Okay, now that entrap air bubble in between voids of the aggregates, which then act as flexible bearings. Okay, so these air bubbles act as flexible bearings. Okay, and they slip over each other. Okay, so if the slipping action has improved, then that means workability has improved, and they modify the properties of concrete like workability, resistance to frost action, and durability. Okay, now common applications are areas susceptible to frost action. Okay, this word is very important, frost action. Frost action is linked to air entraining admixtures and places to improve workability. The examples are resins, stearic acid, oleic acid, hydrogen peroxide, and aluminium powder. Okay, in this oleic acid, stearic acid, and aluminium powder is very important. Okay, so these are some of the types. Goals of admixtures. See, goals of admixture, I have told you in the introduction part, their goal is to improve the properties of concrete which the parent material does not have. Okay, so at times you require early hardening, so in that case you will use accelerator. At times you require concrete to harden slowly, in that case you will use retarders. Okay, at times like in frost prone area, you use air entraining admixtures. Okay, so these will provide beneficial properties to the concrete, and they are used only in minute quantities. Okay, you know that often we are talking about 0.1 to 0.5%, so they are even less than 1%. Okay, frost action. What is frost action? See, frost action, when the in the voids, if water is present in concrete surface, if in concrete, inside the concrete, if there is water present and if the temperature is goes below zero, okay, it goes in the below zero, then that water will turn into ice, and you know that volume of ice is greater than the volume of water at the same content, so that will lead to the cracks. Okay, so that is very harmful to the concrete. Okay, so that is known as the frost action. So air entraining mixtures prevent that. Okay, also one more point to mention here, these are used in very less amount. Okay, air entraining admixture, because they reduce strength. Okay, so 1% air roughly reduces 5% of strength. Okay, so this is also one more point from objective point of view. You may be asked in the form of statements. Okay, so does air entraining mixture reduce strength? Yes, it reduces strength. Okay, 1% air reduces about 5% of the strength. Okay, so this is the theory part. Now we'll move to the questions. Okay, see, this is a small topic, but very many questions are asked from admixtures. So it is a very scoring topic. You should not miss out on these questions. Okay, so which of the following is an example of plasticizer? Okay, plasticizers, as we all know, are water reducing admixtures. Okay, now hydroxylated carboxylic acid. Okay. Then B option is fluorosilicate, C is gypsum, and D is surki. Okay. Now surki is a building material, as you all know, broken bricks. Surki is broken bricks. So this is not a plasticizer. Gypsum, as you know, calcium sulfate. It is a retarder. Okay. Fluorosilicate. I have told you what are silicates. Silicates are accelerators. Okay. So correct option is option A. That is hydroxylated carboxylic acid. Okay. Yes. Many of you have answered it correctly. Yes. Correct. Okay. So fluorosilicate, I have told you various type of silicates act as accelerator, and fluorosilicate is among one accelerator. Gypsum is retarder, and surki are the broken bricks, so they act as a building material. Okay. Now, second question: which of the following is not a retarding admixture? Okay, retarding admixture. Okay. Now with retarding, I have told you TCS and also gypsum. Okay. So tartaric acid, yes, it is a retarding admixture. Sugar, yes, definitely. Gypsum is also a retarding admixture. Sodium silicate. Now sodium, as you all know, silicates are accelerators. Okay. So our answer is B. Okay. So I hope everyone got this point also. Okay. Now coming to the question number 3. Now you have to match. Okay. You have given with gypsum, calcium lignosulfate, air entering admixture, and calcium chloride. You have to match these with. Okay. So quickly solve this question and give me an answer. Now gypsum. What is gypsum? Gypsum is a retarder. Okay. So P3 Q R S. Okay. So gypsum is a what retarder? Calcium lignosulfate. It is water reducer. Okay. Then air entering admixtures. These reduce segregation. Okay. And calcium chloride is an accelerator 1. So 3, 2, 4, 1. 4, 2, 3, 1. 1, 2, 3, 4. 3, 2, 4, 1. Yes. C is the correct answer. Yes. Almost everyone has solved it correctly very well. Okay. So this is question number 3. Now coming to the question number 4. Addition of calcium chloride in concrete results in. Okay. Now calcium chloride, you all know, it is an accelerator. Okay. So the first point, increased rate of gain of strength. Yes, it will, because accelerator, increased rate of gain of early strength will be attained. Okay. Okay. So increased rate of gain of strength. Okay. Now reduction in curing period. Yes, definitely. This is also correct. Okay. Retardation of loss of moisture. Yes, because early strength it will gain. Okay. So loss of moisture will be prevented. Okay. So correct option to this is all of the options are correct. Okay. So this is question number 4. It will lead to increased rate of gain of strength, reduction in curing period, and retardation of loss of moisture. So with the like you are solving this question, so you should add this point to your knowledge. Okay, because it may happen so that the question may be asked in a different way. So you should note that accelerators have these properties. Okay, so you should remember these one. Now question number 5. Which of the following properties of a plastic concrete is modified by air entraining admixtures? Okay, so air entraining admixtures improve workability. Yes, they modify the workability. Segregation, yes, they prevent segregation. Okay, bleeding, yes, segregation and bleeding both they prevent. Okay, so all the options are correct. Okay, so these are the properties of air entraining admixtures. Okay, add to your knowledge. Difference between retarder and water reducer. See, retarder is it is slowing the hydration, okay, and water reducer is permitting same workability at reduced water content or same water content at higher workability, okay. So this is retarded, the functions are different, okay. Now coming to the question number 6, consider the following statements about air entraining admixtures, okay. I think these two are more or less the same questions, okay. So first is improve workability, yes. Improve workability, yes, definitely they improve workability. Improve durability, yes, durability is action against the chemicals and foreign materials, okay. Reduce segregation, yes, and decrease concrete density, yes, because they are introducing air, okay, and air is weightless, so they are decreasing the concrete density as well. So correct option is A, 1, 2, 3, 4, okay. All other options are incorrect or partially correct, okay. So 1, 2, 3, 4 is the correct option. Now, which of the following is a water reducing admixture? Now, water reducing admixture is nothing but plasticizer, okay. So plasticizers, first is calcium lignosulfate, second is vinsol resin, barium chloride and fly ash, okay. So if I talk about the fly ash is a pozzolanic material, okay. So this is not a water reducing admixture. Barium chloride, it acts as accelerator, okay. Resin, okay, resin acts as air entrainer, okay. So lignosulfate is the correct answer to this question, okay. Now the last question for today's session. The vegetable oils and fats when added to concrete produce which type of admixtures, okay. Accelerator, superplasticizer, retarder or air entrainers, okay. So they act as the air entrainers. This is also one type of air entraining admixtures, okay. Please add that to your notes, okay. Vegetable oils and fats, okay. So vegetable oil and fats comes under the air entraining admixtures, okay. But when we add query I am getting, but when we add fly ash, it reduces water. It reduces, fly ash primarily reduces the amount of cement, okay. It brings economy to the concrete because partially you replace cement with fly ash, okay. So partially certain fraction of cement is reduced and it is replaced with fly ash, and fly ash, you know, it is a byproduct of thermal plants, okay. So it is very cheap to get, okay, compared to cement. That's why the fly ash rich cement are often cheaper than the OPC, okay. Okay, so if you have any more queries you can post, okay. We have almost come to the end of this session now. So I think I hope this session was equally helpful to you, okay. We are done with 3 sessions. We have one more building material session scheduled, okay, that is of concrete, okay. It will be live on Wednesday, same time 6 p.m, okay, and after that we'll move to the different subject, okay. So please, I'm getting a query, just wait. So what is zeta potential? See, zeta potential is linked to the flocculation process, coagulation and flocculation process, okay. So in that, in order to deflocculate the sewage, you have to break a threshold of energy, okay. After that only you will be able to deflocculate the sewage. So that energy, okay, is known as the zeta potential, okay. Okay. So thank you for watching this video. I hope this was helpful to you, and please rejoin the session on Wednesday 6 p.m. Okay. Till then, have a great day and prepare very well for your exams, forthcoming examinations. Okay.